Okay, let's talk about exponent rules. And not only am I going to talk about the rules and tell you what they are, I'm going to describe why they work the way they work. Now, my advice for you, know why they work the way they do. That way it's easier to remember. You won't forget them. So here's the actual rules, and we're going to go through them one at a time. And I'm going to explain not just the rule, but why it works. First one being the product rule. So we're multiplying together like x squared times x third. You need to know what that means. X squared actually means x times x. X to the third means x times x times x. So we're multiplying x squared and x to the third together. So therefore, we're simply counting x's. There's 2 x's, 3 more x's. That's a total of 5 x's. That's why, in order to multiply, we actually add the exponents. The second one, what if you have a power to a power? So that's like x squared to the third power, not x squared times x to the third. So a third power means you've got 3 of something. So you have x squared, and x squared, which now is the exact same rule as the previous one. If you were to see how many x's you have, 2, 4, 6, so that's x to the 6th power. The shortcut, a power to a power, we're going to multiply these powers together. 2 times 3 gives you 6. Next one, what happens when we actually divide? The quotient rule. So in order to multiply, we add. So you've got an idea of how we're going to actually divide. So let's say you have x to the third divided by x to the first. So that means you have a total of 3 x's on top. You have a single x on bottom. We're going to cancel out whatever's on bottom, and we're going to see how many we have left. So that gives you x to the 2nd power. So how are we going to actually do that? You can just subtract those. But just know, why are you subtracting? You're seeing which one there's more of, top or bottom, and how many more there are. Let's work one more of those. What if there's more on bottom? Let's do x squared over x to the 5th. Again, what if there's 5 on bottom and only 2 on top? Well, both of them on top gets canceled with 2 of them on bottom. So these 2 gets completely canceled with 2 of these, and it leaves you with 3 of them. There's no more x's. Don't leave the x up on top. There's nothing left on top. We're going to put a 1. So now you have 1 over x to the third. What's the easy way of doing that? If there's 5 on bottom and 2 on top, when you subtract, you get 3. Since there's more on bottom, put your answer on bottom. And then always put a 1 anytime that everything cancels. So that's your rules of quotient rules. Next up, what happens when there's negative exponents? So that would be like x to the negative 3 power. We don't want to work with negative exponents. How can I make them positive? Just move them. Draw your fraction bar, and if an exponent is negative, now we're not saying there's a negative out front. That's something completely different. But if an exponent is negative, once it comes to the bottom, bring the x with it. You now have positive x to the positive 3 on bottom. Again, anytime there's nothing left, put a 1. What if the negatives were on bottom? What if it's 1 over x to the negative 4? Right the opposite, bring it to the top. So it'd be an x to the 4th on top. You can put a 1 on bottom, but you don't have to, because we know we don't have to put that 1 in the denominator. Next up, kind of the same thing. I'm not going to have to write this down, though. Anytime it's a fraction to a negative power, all you've got to do is flip the fraction and change the negative to a positive. So you can show why it's true by working this out completely, but a fraction to a negative, flip the fraction, now it's positive. Anything to a 0 power will always be 1. Example, even if you had 2x squared y to the third plus 4 y to the 2nd to the 0 power, it's 1. Okay, and then the last one, we've done this one in other lessons, rational exponents. So x to the 2/3 power, anytime you have anything, let's do actually 16 to the 3/2. Anytime you have a number to a fraction power, or anything to a fraction power, it can be rewritten. The bottom number's a radical, so it'd be the 2nd root. You can put a 2 there if you want to, but that's understood to be a square root of 16 raised to the top power. So those can be rewritten in radical form. Now, one last thing to cover. Notice we have multiplication and division, and a lot of times people ask, well, why is there no rule for addition and subtraction? And I just want to remind you of something real quick. In order to add or subtract anything in algebra, they must be alike. These are not alike, okay? They cannot be added, and even if it was 5x squared minus x, they cannot be subtracted because they're not alike. You can multiply and divide anything, but you can only add and subtract when things are alike, so that's why there's no rule for addition and subtraction.